The quadratic formula is another method for solving quadratic equations. We find the quadratic formula from completing the square. It's a derivation that I'm going to show you now. General form is ax squared bx and c equals 0 for any numbers a, b, and c. A can't be 0, otherwise we don't have a quadratic. So to complete the square, I would start by factoring a out of the first two terms. Now, I'm going to leave some space here, and I'm going to isolate the constant term c to the right side. We know from completing the square that we need half of this number to be squared. So I'm going to add it, and I'm going to subtract it as well to retain balance. These three terms here form the perfect square trinomial. So I'm going to write x plus b over 2a all squared. This is my binomial square. And I'm going to have a times negative b over 2a squared. It's not the negative being squared. That was a subtraction of something being squared. Alright? So, I'll keep writing this binomial term because we're not going to deal with it for a few steps until we clean up the right side here. This is a negative term, so if I remove it to the right side and isolate it, it'll become positive. And I will have positive b squared. The 2 gets squared, so I have 4. The a is squared on the denominator, but there's an a numerator, so I just have a. Now, I'm going to be subtracting c, but I want a common denominator of 4a, so that's going to be 4a over 4a, or 1 times c over 4a. Just check that works, see that that equals c. So that's this term. I did that so I could get a common denominator. Let's put these together with their common denominator, and I get b squared minus 4ac. The left side is still a bracket x plus b over 2a all squared, my binomial square. My next step will be to remove the a factor here by dividing. So I still have my binomial square, but if I'm dividing, this is going to become 4a times a, or a squared. My next step to solve, now at this point I would have completed the square, one of these steps here, but my goal here is to solve for x. So I want to remove squaring now. That's going to require me to square root both sides, so this is going to be 2a. There are going to be both a positive and negative value, and this is going to be b squared minus 4ac inside the radical. And note, you can think about this, if I had something like 9 minus 4 in a radical, that does not equal 3 minus 2. There's a temptation sometimes to take that radical, apply it to the b squared, and simplify. That can't be done in the same way that this can't be done over here with these numbers. You can pause and think about that if you need to. I'm almost done. I need x isolated. I need to remove this term. So I'm going to subtract it from both sides. And you can see that we have a 2a denominator on both. So I'm just going to put it into the numerator. Negative b, because it was positive b here, plus or minus my b squared minus 4ac. This is the quadratic formula. You may want to replay all of that just so you can see how that was all derived. Now, this is something you need to remember and memorize, because we're going to use it quite often. I'm going to give a couple of examples now to show you how this can get applied, and I'll make up a few cases for you here. So using the quadratic formula, solve for x. So the first one, I'm going to give you x squared over 12 plus x over 4 equals 1 over 3. Now, I could do this problem two ways. Remember, ax squared, bx, and c equals 0 is the general form of a quadratic. I could consider 1 over 12 to be a, 1 over 4 to be b, and if I bring this term to the right side, negative 1/3 could be like my c, and then equals 0 because I moved that term over. However, that's a bunch of fractions, and it's sort of annoying to have to deal with fractions when you don't have to. So let's multiply by the LCD of 12. It's an equation, so as long as I do it uniformly to all the terms, I'm going to maintain equality. This is a lot easier to deal with. And I want all the terms on one side. So this is saying a equals 1, b equals 3, and c equals negative 4. And I want to use that formula up above here for quadratic formula. So the quadratic formula is x equals negative b plus or minus b squared minus 4ac inside of a square root over 2a. So now that I know my a, b, and c, I just need to substitute them into the quadratic formula. B squared minus 4ac over 2a. Alright, what remains to do now is to simplify this. This is 9. Subtracting negative is adding, so I have 9 plus 16. And the denominator is 2 times 1, or just 2. The root of 9 plus 16, well, that's 25. So I can write that down. And so for 2, the root of 25 is the number 5. So let's simplify that. And there are my answers. These are actually 2 answers. So what this means is x equals negative 3 plus 5 over 2, or x equals negative 3 minus 5 over 2. Negative 3 plus 5 is 2, 2 over 2 is 1, and negative 3 minus 5 is negative 8 over 2, negative 4. These are my 2 roots. So that's the basics of how it works. You can get lots of other types of quadratic equations. Let me give you another one that looks pretty different. And I'll show you that, in fact, once you do a little bit of manipulation, all of these problems end up becoming quite similar to each other. The goal is to take what's given. So in this form, see how I have binomial products, that's going to make x squared, and I have a distributive property making x squared. So this is a quadratic. So I'm going to want to expand this, all the terms, and I'm going to want to gather all the terms together. I have more x squareds over here, so let's make all the terms on the right side. I'm going to subtract 2x. I'm going to add 8. So my a is 1, my b is negative 8, my c is positive 8, and I put them into the quadratic formula. It's a good idea to write down the quadratic formula every time, and that way you're going to be able to memorize it quicker. So x equals negative 8, or positive 8, negative 8 being squared, minus 4ac all over 2 times a. So that's 8. This is positive 64. It's a negative number being squared. I'm subtracting 32. Denominator is 2. Okay. And there are often a few steps involved in simplifying the quadratic formula, as I'm going to show you here. The root of 32, well, that's 16 times 2 in a radical, and the root of 16 is 4. So I'm going to take out perfect squares, leaving behind the other factors. I'm now going to look at the 8, 4, and 2, recognizing they have a common factor of 2. So I'm going to remove that factor of 2 on the numerator. See how 2 times 4 is 8, and 2 times 2 makes 4. And I'm going to divide out those 2's, and I get the answer 4 plus or minus 2 root 2, which are irrational numbered roots. So as x-intercepts, those wouldn't cross the axis at a nice place. Anyway, there's a couple of examples to help you with this, and you need to memorize the quadratic formula and make sure your quadratics are always set in general form like this example and the previous one, and then you're good to go.